The longest overlap, also known as suffix and prefix matching problem, is a problem where we have to find the longest overlap between the suffix of one string and the prefix of another string. Suffix is the word that comes at the end of a string, and the prefix is the word that comes at the start of the string. So they must match, like CDE here matches. So this is the longest overlap. As we can notice that there is another overlap as FG, but CDE has the maximum length, so we returned it as the longest overlap of the maximum length. The algorithm we're going to use is brute force algorithm. So we're going to simply follow the problem's definition by checking each possible suffix of the first string against the corresponding prefix of the second string. We're going to have to go through two separate for loops, one that checks the suffix of the first string with the prefix of the second string, and the second loop just does the same job but in a reversed order by checking the suffix of the second string with the prefix of the first string to make sure that if there is an overlap, it's not missed, we don't miss an overlap, and also if there are two overlaps, we get the one with the maximum length. In this, we're going to store the suffix starting from I to the end of the string. So initially, it's going to be the whole word of the first string, and make sure it's less than or equals to the length of the second string. If it is, if this condition is satisfied, we're going to check the second condition. If this suffix is equals to the prefix of the second string by tracking the index from the very first letter to the until the length of the suffix. If they are equal, then we're gonna store the maximum length to the length of the suffix. So initially, the whole strings are compared, and we keep comparing the changing suffix of A with the changing prefix of B. How are the suffix and prefix are gonna change? By incrementing I. By incrementing I, we're reducing the length of suffix and as well as the length of the prefix because it's dependent on suffix. We do the same thing in this for loop, but by reversing order as we just said, and at the end we return the maximum length. Let's see the implementation here. We have this example using Python code. We have two for loops as we just said. The suffix is assigned to the suffix of the first string, and we are storing its length here. If this length is less than the length of the second string, then we're gonna see. Let's trace this on this example, human and man. We're gonna work on human because the first for loop checks the suffix of the first string. So we're gonna work on the first string now. Is its length less than or equals to man? No, of course. So we're gonna increment I. So now we're standing on you. This is how we increment. It feels like we're shifting, but then we're comparing again, and it's still bigger than. So we're gonna shift again. Now they have the same length. Because it's less than or equal, then we're going to check the second condition. Is this suffix, which is man, equals to this prefix, which is also man? Yes, it is. Then we get it as the longest overlap. So if this for loop does the job, why do we have this for loop? Because if we pass parameters like this example in this order, this for loop is going to detect the overlap, but the initial for loop won't predict it. So let's see, because in this we are going to work with the second string, because the second for loop checks the suffixes of the second string. So we're going to work with the second string. Do they have the same size? Yeah, they do. Then the first condition is satisfied. But are they the same? Is arrays the same as paper? No, it is not. So we're gonna increment I by shifting, and by this we're comparing this part with only this part. 4 letters for 4 letters. So they are not equal. So we're gonna increment again and compare era to PER, and they are not the same. We're gonna increment again and compare ER to ER. Now we have a matching string, which is the overlap that we're searching for, and it's gonna get its length. Let's see. In this example here, the longest overlapping substring is using ABCD and CDEFG. It's gonna return CDE of length 3. Let's also try this example here. I have man Hulk. That's an example I came up with. Man Hulk and Hulk Man, because it has two overlaps, but one has a bigger length. So let's see if it gets the one with the longest overlap. Yeah, Hulk has length of 4. The longest overlapping substring is Hulk of length 4, and it didn't get man because Hulk has a longest string. There are also some examples we can try, but we already traced these two. Let's see if we put him and woman. By shifting, we want to get an overlap, so we're expecting a 0. Let's see. Yeah, it gave me an empty string of length 0, so no overlap in this example. So let's see the analysis of this algorithm. The complexity analysis of the longest overlap, time complexity is going to be the big O of length 1, which is the length of the first string, plus the length 2. It's not n power 2 because this is not a nested loop. These two loops are separate, so we're going to have the summation of them, or approximately the maximum length of them. And the worst case and average case and best case are the same, since we always have to go through the same for loops until the end of the two strings. And time complexity is going to be O of 1, since the algorithm doesn't take up more space regarding the few variables used, like storing lengths of the strings. These don't count. The space used by these variables is independent of the input size and can be considered constant, so space complexity is going to be big O of 1.